Hi everyone, this is the eighth group of CS350 in the fall semester of 2021. Our group members are Xiangqi, Letian, Cameron, and Ali. What we are going to introduce you today is our integrated smart home solution. Okay, next page. We realized and integrated the home infrastructure construction plan through the one host, the two networks, and N sensors. Through network integration and equipment integration, we realize the intelligent connection and coordination of the whole house's in hardware, sound, light, water, and electricity systems. Through the four basic capabilities, it forms the core architecture of smart home. Next play, please. And establishes a wealth of smart home things model to connect various sensor data and real-time network data. A complex logical calculations continue to polish high-quality smart things experience for users. Next page, please. The system integrates an intuitive and easy to control home environment, integrates many different functions into one unit, and has high usability. Users don't need to control so many remote controls to enjoy the comfortable and seamless indoor environment experience throughout the day. We will do our best to create a comfortable and convenient living environment for our user groups. Next, please.
Okay, so the perfect servant is a self-sustained product which uses a combination of the systems in one product. And the process itself resembles a life cycle. So the sensors take the data from the environment and passes it to the app. The app passes the required data to the devices, and devices change the environment. So that is how the cycle works. And you can see the diagram of the cycle here. So this is mainly what I just said. There are 5 main product features. First one is that it controls the environment and it controls the temperature, humidity, and smoke detection. The second one is that it recognizes and learns the pattern of the user and provides the relevant features depending on the pattern. Then it controls smart facilities using the integrated control using the smart app. Fourthly, it establishes the security of the user by providing by tracking the motion and temperature, and then it protects the privacy using the fingerprint and scan lip recognition. So the operating environment for the app, the user needs to have a phone having either Android or 8.0 and above, or iOS 13.0 and above. For hardware, the memory size should be 1 GB or more, and Bluetooth 3.0 and above. And the devices should be compatible as well, and they have to have either Wi-Fi or Bluetooth models. So the assumptions that we consider during all the facts given are that the depending devices experiencing issues should not bring a total failure of the whole product. So all other devices should continue working and the app should work. The OS under which app works should not have unintended bugs and crashes. And then there are no third-party apps which interfere with the function of the app. All third-party devices which are connected to the app should work under the constant load and in the prolonged periods of times. Then the cameras tracking the user's behavior should be able to catch the user's presence most of the time. So there should be no issues with that. Then users should be constantly keeping up with the updates. Then users should spend a considerable amount of time at home so that the pattern could normally realize its feature. And then the user is in possession of the phone every time he's out of the house.
Okay, regarding the functional requirements, our team specifically found out 18 related functional requirements based on the positioning of our products, and the specified requirements should be prioritized based on our team's own criteria. I will focus on some of the more important parts. So the next slide. The next, please. The first is continuous machine learning to build a more perfect servant. The device will continuously learn the user's usage habit through machine learning algorithm and record the surrounding environment parameters through the sensors to gradually form a more perfect system. And the second one is realize response and convenient operation. The device responds to user instructions and make corresponding changes. And the last one will be the real-time monitoring is more assured. Users can remotely view various environmental parameters at home through mobile phone anytime, anywhere. So next, there will be the use case diagram. Firstly, we recognize two primary actors, which is the user and non-log user. And the non-log user is a generalization of the user. They can do register and log in to get into our account and start to do the functions like add new function when they purchase new equipment of our company, or set the goal of the system. For example, the target temperature, set the light status, set the music or something else. Then they can get maybe they can get the situation at home remotely. For example, you are in the school and you can watch out everything in your home. And the last one, they can make short voice commands, and the host system will recognize the command and go give you some response accordingly. In the right side, there will be some secondary actors like database, sensors, and host system. They are the LLT stuff for the external system. When they recognize some command from the user, they will use do some response and record the comment and learn that habit and create a more perfect system. Okay, then I will explain some use case description in the next slide. What I want to explain is game lifestyle suggestion, which I think is quite an important use case. There will be a user habit file in the system, which records every command and environmental parameters of the command amount, and use this file as the basis for making recommendations. And according to users' usual habit, suggestions will be made to user, and the user can decide whether to accept those suggestions. What can go wrong is to fail to give a suggestion, or the suggestion was rejected by the user. And I will explain the specific steps in the next slide. First, when the sensor records the current environmental parameters, for example, the temperature and the light status, and after the database get those data, they will match the all the exclusive custom profile and find out the similar situation and try to do the history entry again. The system found that when similar environmental parameter appeared, the user lowered the temperature of the air conditioner, for example, and the system proposed to the user to lower the temperature. It's quite like reduce some command, and the user will decide whether to accept those suggestions. When he accept that suggestion, this system will start to set the lower temperature and record this again. After this, I will show the screen's diagram in the next slide. As I said before, this information exchange will displayed in the figure in the time order. One thing to note is there will be an alternative, whether there will be a similar situation in the database. If there is not, there will be no suggestion from the system. Okay, that's all my part.
So I'll talk about the interface now. The interface of the application is probably enough to guide even the first-time user and any demographic group. And a tutorial will be provided for any first-time users to guide them through the app, and so that they can explore the application fully and its features. And the multimedia interface in the application, icons and images allow the user to engage in it fully. So these are the startup and sign-in screen. The startup screen promotes and introduces the company, and the sign-in screen basically allows you to sign in with email or external account if you're using it the first time, and allows you to sign in with fingerprint for any subsequent uses, which allows a faster and more convenient access. Next slide. So these are the home and update screens. These are, I think, very important screens. The home screen allows navigation to any of the other features of the app, such as personalization, which is given in the top left corner as My PS. And it allows you to go to the device panel and manually change your device operation. Right now, it shows you the currently running devices, and by clicking on any of these places in My Places, you can change which devices are running and which are not, and change their temperature or whatnot. And the daily update section basically gives you the recommendations of your device schedules based on your habits. It gives you security alerts, and it notifies you if any device was toggled on or off automatically. And it also allows you to turn the protection mode on or off, which is basically the main security system of your home automation. Next slide, please. So this is the ID verification through fingerprint, or you can just input your password. This screen is basically if you want to change your personalization settings, or you can, or if you want to turn on or off the protection mode. Next slide. So this is basically the personalization settings I was talking about. Here you can change your device schedules, running hours. You can control the intensity of temperature or light, and you can change things about your devices, add new ones or delete some. You can change settings about your protection mode, which things you want to protect more or less, and turn off some features even. And in the My Places, when you can add more places to your application to basically interact with. Next slide. So this is the most important screen panel. I think this shows you the main devices and how you'll interact with them. For example, the lamp can be adjusted with its brightness, the AC has temperature, the TV has power, and the music has just play buttons and play buttons. So this is just a simple interface, and it has the potential for even more features. So yeah, that's it for the interface.
Okay, we focused on 11 non-functional modules. It should have user adjustable buttons and layout. And in addition, the wording of each definition in the application should be self-explanatory. All users will receive a comprehensive guide and a quick reference guide. The system should be reliable and robust, allowing users to feel that's reliable when they want to use our application. Next, please. The system should be interactive, and the delay between actions should be less or equal to the response time of most software in the market now. The input and output are all common signals versions of market equipment. Due to the diversification of smart devices, the part will be updated frequently, and the specific update status will depend on the device update. Next, please. The target equipment of the operation is a smart terminal represented by our mobile phone. We allow the system to access the device and record the status of the device after each visit. The physical security is not a problem because the system is designed to provide services and it's not a tangible device. So like that. Finally, the App Store will be responsible for system installation. After the app is put on the shelf, that could be available, we think. So that's the things we need to focus on our non-functional requirements. That is the quality attribute. Okay, next, please. So that's all. Thank you for watching. That's our project. If you have any problems, please feel to contact with us. Thank you.